Okay.
Laser tag.
That's the first time I've ever been compared to a laser tag instructor. All right. We have a.
Hi,
today
my gym class.
we're going to talk to. All right. So we're going to talk about how various elements combine. Hold on. Let me see if I can get that.
Oh, that's a 1. I thought that was
How different elements combine to form compounds, and there are predictable rules that are followed that determines why certain elements combine and in what proportions. So if we think about, and we talked about this a little bit yesterday, that really, if we think about it, atoms would like to be stable. Okay? And for an atom, being stable means having a full outermost shell of electrons. Okay? And so what that means is, if an atom has an outer shell that's not completely filled, it could gain some electrons to fill up that outer shell. Or there's another option. If it has several electron shells that are full, and then one extra in the outermost shell, what could it do to become stable, Bianca?
It could give it away.
Yeah, it could get rid of that one electron. Then the shell behind it is full, and it's stable. And this is why various elements form compounds with each other. Okay? So we call this the octet rule. Now, atoms will form compounds with other atoms in order to reach a full outer energy level. And often it means filling up to get to the number 8. Generally, any atom that has less than 4 electrons in its outermost shell will get rid of those electrons when it's forming a compound. Okay, so if we have an atom that has 2 electrons in its outer shell, just easier to get rid of those 2 rather than try and gain 6 to get up to a full 8 in that outer
So
shell.
it's always 8?
Yes. Atoms that have more than 4 electrons in the outer shell, they'll try to gain some electrons to reach 8. Okay? So atoms can gain or lose electrons to reach a full outer shell.
How do they lose them?
Basically, sort of, they can give them away. So give them away to another atom. So if an atom has 1 extra electron in its outer shell and wants to get rid of it, who's it going to find? Cole?
A compound that needs another one?
Yeah, an atom that's looking to gain an electron. Okay? That would be one with how many in its outermost shell? 7. So then the atom with 1 electron in its outer shell can give that away. The atom that has 7 in its outer shell will gain it, and it will have 8, and they'll both be happy. They've made each other happy. They're a nice couple. Sometimes, though, we'll leave it there for right now. All right. Before we get into the forming of compounds, though, we're going to talk about something called the oxidation number. Herschel, you have a question?
Yeah, do the atoms lose power if they
No.
get rid of...
Nope.
So
They
what-
become stable. They become more stable. All right, so those outermost electrons are the electrons really that we're concerned about. We talked yesterday about these numbers on the bottom, the electron configuration. We're concerned about the last number generally. Those are called the valence electrons. Okay? Valence electrons are found in the outermost shell, the outermost energy level. And you probably have already noticed, and we talked about it when we talked about Mendeleev in the periodic table, all elements in the same group, they all have the same number of valence electrons. If you look in group 1, all of those elements, okay, lithium, sodium, potassium, they all have 1 outer electron, 1 valence electron. Everything in the second group, beryllium, magnesium, calcium, they all have 2 electrons in the outermost shell. So they follow this predictable pattern. Morgan?
How does that have 8 between?
Yeah, so it's actually much more complex than I'm making it sound, because there are subshells and different energy levels can hold different amounts. For example, the very first energy level can only hold a maximum of how many? 2. The second energy level can hold up to 8. The third can hold 18, and so forth. So they can hold more and more electrons, but we don't really have to be concerned with that. All you need to know, yeah, I'm right behind the soccer team picture. All you need to know is that these shells are filled up until you get to the last one. Nicole?
How do they know if it's stable? Like, how come a 3 is stable and the B, but like 7 isn't stable?
This is not, boron 3 is not stable because it's not full.
Oh.
Because this energy level can hold how many more electrons? 5 more. All right, so these are the electron shells, okay? And then what we're going to be looking at is something called the oxidation number. And in some periodic tables, it's given to you. I believe on your agenda periodic table, they give you all the oxidation numbers. But we need to know how to figure that out ourselves. So your periodic table that I gave you does not have these oxidation numbers. All right. So, if we look at some examples, this is sodium. And its outermost energy level, how many valence electrons does sodium have? Emma?
1.
Has 1 valence electron. So its oxidation number, you could think about it as, does it have extra electrons or is it missing electrons to become stable? What about sodium? Is it extra or is it missing? Has extra. How many extra electrons does it have?
Oh, okay.
1.
Yeah.
So what do you think its oxidation number is?
Plus 1.
Plus 1. Think about the plus sort of as extra electrons that it'd like to actually get rid of.
Oh, if it's less.
4.
Yes. Let's look at that. Chlorine, for example. How many valence electrons in chlorine? 7. Okay. So does it have extra electrons or missing?
Missing.
Yeah, and what does it want to get up to?
18.
So what's its oxidation number?
No.
Minus 1. How many electrons is it missing? 1. It's minus 1.
Don't you have to get
Missing
to
1 electron to get up to 8 to make it a full outer shell and be happy.
Didn't you say? Yeah.
So that we're going to say that 8 is full in the outer shell for that. It's when we look at the subshells, it can go higher. It can go to 18. Or if you look at larger atoms, it can go up to 32 and so on. So, but for our purposes, we're just going to say it needs to get up to 8 there. Okay, and that shell, that energy level will be full. Jonathan?
I'm pretty sure Mr. Curie wrote that. It said the negative one was sodium, but it really should be chlorine.
Oh, did it say sodium there? All right.
Oh, yeah.
All right, carbon. Now, carbon is a little different. How many electrons and valence electrons does carbon have? 4. So what do you think about carbon? Jonathan? Maybe. Yeah, it could be either way. It's just as easy to gain 4 as it is to lose 4. So sometimes it has a positive oxidation number, plus 4. Sometimes it has a negative, minus 4. It depends on what other element it is combining with. Gallium. 3 valence electrons. What's its oxidation number? Chloe? Plus 3. 3 extra electrons.
Wait, why is it plus 3?
Because it has 3 extra that it would like to get rid of.
Oh, so if there's 4.
It's plus or minus.
Does it stay the same like element when it like loses or gains?
Yeah, because it's the protons that determine what element.
Does any atoms, like, so hydrogen, like, they only have 1
Mhm.
electron?
Yep.
So what if they were to share, with, like, hydrogen and neutron?
They do sometimes share electrons. So atoms can share electrons sometimes with another atom. Okay. Other times they can completely give that electron away. It depends, and there's different types. There's ionic bonds and covalent bonds, but we're not going to get into those details. Okay, but yes, that can happen. Olivia?
I don't get how you know it's like less than.
Think about it as extra or missing. The atom wants to do whatever's easiest. So if it has just 1 or 2 or 3 electrons in the outer shell, it's easiest just to get rid of them. So it has extra electrons. That's why it's plus.
So what's next?
So if it had 5 or 6 or 7, it's missing electrons to get to 8. It's easier just to find some electrons.
Like for the GA
Yep.
was +3, and
Yep.
then for this one it was minus. So
Yep.
how do you know what one the outer shell will be like?
It's the outer, the last number is the outermost valence electrons.
Okay.
Okay? So let's look at some examples. Potassium has 1 valence electron in its outermost shell. So what is its oxidation number? Nicholas? +1. Has 1 extra electron that it would like to just get rid of. And then it would be happy. How about calcium? Calcium has 2 electrons in its outermost shell.
Oh.
Morgan, what would its oxidation number be?
+2.
+2. It has 2 extra electrons. Lead has 4 in its outer shell. Therefore, it's in that weird spot. Nicole?
+4 or minus.
It could be +4, it could be -4.
Oh, so like if it's like 4 and up, if like
Above 4.
would be negative.
So krypton, yes. Krypton,
I get it.
the element, not the planet, has 8 electrons in its outer shell. So what do you think about krypton? Bianca?
It's a noble gas with oxidation number would be 0.
It's 0. These are those noble gases. They don't need anyone else to make them happy. They're happy on their own. They're fine being single. They're stable. They don't need to gain or lose electrons. They don't combine or react with other elements at all. Phosphorus has 5 electrons in its outer shell. Zach, what would its valence oxidation number be?
That would be -4.
Not -4,
Oh, -3.
-3. It's missing 3 electrons to bring it to 8, which would be stable.